Okay, so we've got a correction for GO41B. Okay, so we're going to look at yesterday's assignments, and we're going to do this and make sure you understand where everything's coming from. Make sure when you're looking at this that you know that B and G are in the same position. Okay, so I'm looking at this, so 37 is equal to Y plus 50. So Y is equal to negative 13. And I plug that back in, and I know that this is equal to 37. So it makes sense because we said that they were equal. CD and HG, CD, HJ, not HG, are in the same position. So not only are they in the same position, they're congruent and therefore equal. And so 2x plus 3 is equal to 3x plus 2. And now 3 is equal to x plus 2, and I subtract, and 1 is equal to x. So I plop that in, and I find that CD is 5, and HJ is equal to 5 as well. Now, when I'm looking at angle C and angle H, C and H, they are in the same positions. So C and H are in the same position, therefore they are equal. So now 20 is equal to Z plus 10, and 10 is equal to Z. Now I'm supposed to find the measures of the given angles or lengths of the sides. So the measure of angle C is equal to 50 plus 20, which is 70. And the measure of angle H is equal to 60 plus 10, which also is 70. Now AD and FJ are in the same position, so 5B plus 4 is equal to 3B plus 8. 2B plus 4 is equal to 8, and 2B is equal to 4, so B is equal to 2. I plug that back in, and now AD is equal to 5 times 2 plus 4, which equals 14, and I go FJ is equal to 3B plus 8, where 2 is in there as B. Let's fix that. So I got FJ, which equals 2 times B, and I got B, 3 times B. 3 times B, which is 2, plus 8, which is also 14. Now, that's when we're giving a figure congruent statement, and we're able to follow order. Now 5, 6, 7, 8, 9, and 10. Now 7, you got to skip. I didn't notice that when I handed it out. It's just not going to work. So don't even try to get an answer. There isn't anything close. It's just you had to make some assumptions on stuff that just won't be fair for anybody. And 5. Let's look at this. I got kind of a third angle thing going on. I know this is 74 degrees because of the markings here. And I know that this is 5x because they're vertical angles. So that means that I got this is 3x plus 2. And now that I have that information out, and I know all three angles of a triangle are 180 degrees when I add them all up, I have the following relationship. I know that 3x plus 2 plus 74 plus 5x must equal 180. Okay, I know that because of triangle sum theorem. So I'm just going to move this stuff out of the way, this blue, and that's the relationship I'm working with. And I'm going to get my combining like terms on. So I got 8x plus 76 is equal to 180. I've got 8x is equal to 104. Dividing by 8, I will get x is equal to 13. So x is equal to 13. So let's check out some values here. 13 times 5, 5 times 13, that's 5x times x, 5x putting 13 in, is going to give me a 65. So it's 65 degrees here, my bow ties. Okay, then 3 times 5, excuse me, 3 times 13 plus 2 is going to be 41. So this is 41 degrees and so is this. Now 41 degrees plus 65 degrees plus 74 degrees should give me 180. And if I look at 65 and 41, that's going to be 106 plus 74, and that gives me my 180. So we're all good as my check. Now, in 6, please look at the fact that I'm given that these are lengths and that these sides are congruent. What they're asking is find the values of the variables with the given information. No problem. 2x is equal to 10, so x is equal to 5. And that checks out. We're skipping 7, and we're on to 8. Now, corresponding sides. I'm looking at this, and I'm talking about AB and KL are in the same position. So 4 is equal to 2t, so 2 is equal to 2 after I divide. T is equal to 2. Then I'm looking at this, and I look at that C and M are in the same positions. M is 3x. C has to be 45 because triangle congruence triangle sum theorem states that all three angles add up to 180. But when I'm working with a right triangle, the two acute angles, this one here is 45 and this one must add up to 90. So 90 minus 45 is 45 degrees. So I know the measure of angle C is 45 degrees. So since the measure of angle C is equal to the measure of angle M, and C is 45 degrees and M is 3x, x must therefore be 15. Now if I'm looking at 9, I have a relationship here, and if I look this over, I have angle DAC and angle BAC. CA angles BAC, so I got BAC and DAC are in those orders. And so if I talk about the measure of angle DAC is congruent to, not congruent to, equal to, let's clean that up. We have the measure of angle DAC is equal to the measure of angle BAC. And remember, D is in the same position as B, A is in the same position as A, C is in the same position as C. So when I do DAC, BAC, that works. And now I know that DAC is 6x, BAC is 30, so x is 5. My next one, I'm still looking at my triangle congruence statements to actually figure these out. EF and XY are in this, E and YX are in the same. So I know because XY is equal to FE, I know 9 is equal to 3x and x is 3. Because 30, the measure of angle Z, is equal to the measure of angle D, okay, I know that Z, which is 30 degrees, is equal to 2y, and y is equal to 15. Now, in 11, I'm telling you that triangle HLN is congruent to triangle GST. And H is 66 and S is 42. So when I do ones like this, I just kind of quick do a sketch of the two triangles. I try to make them look right. H, L, N, G, S, T in the same order. So I'm told that H is 66. G's got to therefore be 66. They're in the same position. And I'm told S is 42. Well, L is in the same position, 42. So by third angle theorem, I should be able to figure out that N and T are the same angle. Okay, so when I'm talking about 66 plus 42, that third angle is either N or it's T, and this one's T is equal to 180. So this is 108 plus X, it's equal to 180, so X is equal to 72 degrees. So the measure of angle T is 72 degrees, or I can talk about the measure of angle N being 72 degrees. Now in 12, the measures of one angle in a triangle is 80. The other two angles are congruent. What's the measure of each? So if one angle is 80, that means I have an isosceles triangle. This is 80 degrees, and the other two are congruent because they're saying that. And the other two angles are congruent because base angles are congruent in an isosceles. Even if I didn't know that, I knew that I had 180 minus 80, which is 100. Well, the other angles are the same. They are both 50 degrees. Now these last two, we're going to talk about these proofs. Now these two proofs that are sitting on the board, they're similar to the ones we worked on in class. Okay, they're not impossible. So let's just muster through. Let's roll up our sleeves. I'm going to put black in for the things that are given. Problem one, or step one, my statements. I know that AB is parallel to DC. And I know that angle AB, or angle B, is congruent to angle D. I also know that segment AB is congruent to segment DC, and segment BC is congruent to segment AD. And now I'm starting to get worried about some space, so I'm just going to slide this over a little bit so I can fit all this on one line. So it's all fit on one line. So that's given. Okay, not being secretive, that's straight up given to me. And now let's investigate what all these mean. Now, when I'm looking at this, they tell me that AB is parallel to DC. Well, I'm telling you, when they give me parallel lines, I'm thinking alternate interior angles. Okay, so I'm talking about parallel lines, and it's this angle because that transversal sandwiching them. Those two angles are congruent because of parallel lines in that transversal AC. I'm also looking at AC because AC is reflexive property, and if you look at this, the reason I'm about to talk about it being the different direction, A and C are in that order, and then it's C and A in the same order. So I'm going to talk about that reflexive property as flipped. Okay. Now they tell me about B and D, this angle B and this one are already congruent. They tell me about these marked segments that are already congruent to each other. So I'm thinking right now, provided that I have those marked segments, I need one more segment, this one for reflexive. I need two more angles. This one because of alternate interior with this one because of the sandwich with the parallel lines in that transversal, really, AC, and AC being congruent to itself because of reflexive property. Then I have my last thing, angle BCA is congruent to angle DAC because of third angle theorem. That's my step in order to prove triangle ABC congruent to triangle CDA. Now remember, today we're really working with all the sides and all the angles being congruent to one another. So I'm just going to step through and talk about my proof the way I just did it with you. So in step 2, I'm going to use the fact that segment AB is parallel to segment DC and work on my alternate interior angle. So that's the first thing I'm going to do. I'm going to look at angle BAC, being congruent with, and remember I went BAC, being congruent with DCA, angle DCA, because of alternate interior angles theorem. Okay, now I'm going to talk about my reflexive property. Segment AC is congruent to segment CA. Okay, and the reason why I'm splitting it is because A and C are split here. Okay, reflexive property. I shouldn't say split, they're switched around. Reflexive property of congruence. Now, I've got that reflexive property, so I'm going to mark those. I've got this angle and this angle. because of alternate interiors. Now I'm going to go after my third angle theorem. So in step 4, I have angle DAC congruent to angle BCA because of third angle theorem. Now my last step in black, because it was part of the stuff that was provided to me at the beginning, 5, triangle ABC, that's what I'm supposed to prove, the very last step, is congruent to triangle CDA. Now, keep in mind, it's a different reason than to prove. It's because of definition triangle congruence. Okay, now we're done with that theorem and proof. Let's look on this next one. This one should look kind of familiar. Again, I have parallel lines. Every time I have parallel lines, look for alternate interiors. That's the first thing. Sometimes it's corresponding, but most of the time it's alternate interiors. I've got alternate interiors, and then I've got all right angles congruent with angle A and C being congruent to each other. I don't know they're congruent, I just know they're right angles, so I have to say that angle A and C are congruent because all right angles are congruent. I've got the third angle by third angle theorem. Okay, and then I got DB congruent to BD because of reflexive property. And then I am done proving these two triangles congruent. Okay, so I'm going to give us some more room here and slide this up to there. Okay, so the first thing I'm going to go is my given. Step 1, AB is perpendicular AD. BC is perpendicular to CD. Remember, those make right angles, okay? So AB is congruent to CD, and I'm just going to go in one line. AD is congruent to segment CB, and then my last thing is AB is parallel to CD. This is all given. This is running over into my statement reason. My statement's running over my reasons area. But now the next thing is, I'm looking at this, and I've got perpendicular sides. Well, those perpendiculars make right angles, okay? I have them that they're perpendicular. I do not have that these angles are right yet, but I do know for sure that, and every time I do this, this is a two-step. It's called the perpendicular two-step. That's what we're going to call it. Okay, the perpendicular two-step. I know the perpendicular. I have to say that these angles are right angles by definition of perpendicular lines. So I've got angle DAB is a right, or I'll talk about two of them. Angle DAB and angle BCD are right angles. This is by definition of definition of perpendicular lines. Okay, so that's what that means. Definition of perpendicular lines. That's my step 2. Okay, I have to talk about those two angles being right angles before I can say angle DAB is congruent to angle BCD. All right angles are congruent. Now, that's an actual theorem that was in chapter 2. Now, after I get this done, my next step, I now know that these two right angles are congruent to each other. I'm going to use this fact that AB, well, I want to stay with the angles right now. I'm just going to kind of focus on angles. So I know these two are congruent. I know because of this parallel line with this one that these two angles are congruent because of alternate interior. So that's where I'm going to next, but we'll do that in blue. This will be like this, my alternate interior angles. So I know that in step 4, I have angle ABD congruent to angle CDB because of alternate interior angles theorem. Okay, so I got those, and I'm going to mark those once I've got those. So I got that and that. Remember, I've took care of those. And now I'm going to get my last angle because of third angle theorem. So I've got my angles. I've got third angle theorem. That angle ADB is congruent to angle CBD because of third angle theorem. Okay, now I got one more thing to say. I've got this side. The side here is congruent to itself because reflexive. Because again, DB and BD switch in the congruent statement, I switch them in the reflexive statement. So segment BD is congruent to segment DB because of reflexive property. Of congruence. Okay, my last thing. I know this might seem like it's forever, but I think this makes more sense than it did yesterday even. I have all 6 pieces. I got 3 sides, 3 angles congruent to one another, whether it be given or I was able to find them through the proof to be able to say that triangle ABD is congruent to triangle CDB because of definition. Of triangle congruence. Okay, so that's it for my assignment from 4-1 day 2. Let's look at the notes. Okay, let's look at those notes. Today's objective for 4-2 is prove 2 triangles congruent using side, 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 and side angle side. Now here's the thing. Yesterday you were able to look at things and you had to prove all 6 pieces congruent to all 6 pieces. Today I'm telling you there's a shortcut. And 2 of them require you to know all 3 sides, one of them, and the other one's 2 sides and an included angle. So we're going to cover those. But before we do that, I want you to come up with the 6 pairs of congruent parts and a pair of congruent triangles. These 2 triangles are the ones that are congruent, and I got to check your notes because I have a feeling that when I checked them earlier, it was a mistake. And oh, look at that, there is a mistake. I have triangle ABC congruent to triangle EFG in your notes, and those aren't ABC and EFG. So if you would, right now, make this change of triangle FGH congruent to triangle JKL. Make this change up here in that corner. Okay, make that change, and now put in angle F, angle G, angle H, segment FG, segment GH, and segment FH. And now turn off the video, answer the question, then turn it back on and make sure you can do it. Remember, if you're just copying it down, you're not learning anything. Anybody can copy. I need you to be thinking about these. Now, welcome back. I hope this went well. Remember, order matters. F was first. J is angle J. Okay. G is next. K is next. Angle K. H is last, L is last, angle L. Now, based on those, I'm going to totally use those to help me get my segments. FG, FG, JK. GH, okay, GH, KL. All right, and then I've got FH, FH, JL. And that's corresponding parts. So 6 pairs of congruent parts and a pair of congruent triangles. So we got congruent triangles. That's a triangle congruent statement, and able to line those up. Now remember, today's all about shortcuts. And here's the first one. Side, side, side congruence postulate. If 3 sides, and let's get an angle here, or arrow here to point to. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent because of side, side, side congruence. This is 3 corresponding sides have 3, each side has a pair that's congruent. That's it. If I have just 3 sides, I don't need anything else. That's enough to say 2 triangles are congruent. Now, a second one. These are both postulates. 4.2, side angle side congruence. Now, keep in mind, if 2 sides and in the included angle, this is a big deal. The 2 sides, the 2 congruent sides make the congruent angle. So if it's in this position, okay, like PQ and WX are congruent, QS and XY are congruent, then the included angle is made by the 2 sides that are congruent. Now, so the included angle of the one triangle are congruent to the 2 sides, and the included angle of the second triangle, then the 2 triangles are congruent. These are shortcuts. We don't have to prove everything, okay? Although yesterday I had to do that so we could practice, and we did a lot of practicing, finding out what we needed to prove the whole thing. Now, I have a word bank, and I want you to turn off the video, try it, and then turn it back on and see how you did. Okay, hopefully you got it, but the first thing should be given, right? So I have P, Q, and TS. I have PW and TW, and I have QW and SW. And they are given information. That's the entire given right there. And since I have 3 sides congruent to all 3 sides of the other triangle, I know I'm done. Triangle PQW is congruent to triangle TSW because of side, side, side congruence. Now, this next one, I'm looking at the bow tie configuration. I got a bow tie. What do I know about angle 1 and 2 if it's a bow tie? Vertical something or other. Okay, you try this one. Remember, given, vertical, and then a triangle congruence, and it's not side, side, side. Which one would it be? Turn me off, try it. Okay, welcome back. We've got this going on, and hey, I got my given. I got to pop down. And I got angle 1 congruent to angle 2 because of vertical angle theorem. Okay, that's VAT. Now, if I got that, I got side angle side congruence for the 2 triangles to be congruent, so I'm done. That's quick. That's way faster than it was yesterday. Those triangle congruence things, you know, those proofs that Bloom did in that 4-1 day 2 worksheet, those were tough. Okay, so we've got these. So let's make sure we've got these by practicing. Draw MGT. I've got MGT up there. If you haven't gotten it, you put it in. Use the triangle to answer the questions below. What angle is included between segment GM and segment MT? Now, hopefully, you're guessing that it's the letter between them. So angle M should be there. Which sides include angle T? And that's side TG and side TM. And what angle is included between GT, segment GT, and segment MG? Angle G. That's included. Next, would you use side, 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 or side angle side to prove the triangle congruent? If there's not enough information to prove the triangle is congruent by side, 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 or side angle side, write not enough info. Now, please keep in mind, if you can prove something because of reflexive property, and that'll help, that's good, because reflexive property is there. Or if you have a bow tie, okay? But don't try to make things out of something. Now in 4, I have an angle and 2 sides congruent, but that angle H and angle R are not made by the 2 congruent sides. So we're looking at not enough information at this time. I don't know anything about J and F. In 5, I have EF congruent to itself. EF's congruent to itself. So I have a side angle side with a side angle side, and they're corresponding sides. So I got this congruent because of side angle side, and remember, EF is congruent to EF, reflexive property. Okay. Now in this next one, boy, that looks tough. You know, it'd be really cool if KO was congruent like to OK or something like that because of reflexive. Oh, that's right, it is. Because now I got side, side, side. And then I have to have that one other step with KO congruent to OK, reflexive property. Now in 7, I have reflexive with ZY. I really, truly do. But I don't have an angle that is between ZW and ZY that's congruent to the angle that's between XZ and ZY. If I did, that'd be cool, but I don't. So I gotta say not enough info in this one. Now in this next one, number 8, go for it, see what you know. Okay, I'm hoping that you saw all 3 sides are marked in one triangle and all 3 sides are marked congruent in the other, so therefore it's side, 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 congruence. I don't have to do anything extra. In 9, I got a right triangle congruent to a right triangle because I got side, angle, side, because I can take those 2 right triangles, talk about those angle C and angle F being right angles and all right angles congruent, and I know it's side, angle, side. Try 10, 11, and 12. See how you do on your own. Okay, remember, turn off the video, try 11 and 12, 10, 11, and 12. Now that you're done, I'm looking at this. I know I've got RN reflexive, but I have no other sides here. It'd be really cool if ON was congruent to ER, but I don't know that, so I do not have enough information. In 11, I have the bow tie. Because I have that bow tie, check it out. I've got this congruent to that. I've got this congruent to that, and the 2 angles are vertical angles. So I've got that, and I've got that going on. I should say vertical angles, I should say VAT. Okay, and my last one, although I have a bow tie, did I need it? I shouldn't even worry about bow tie because I have side, side, side in this situation. It's already provided. Yes, the bow tie angles are there. I got angle TDC is congruent to angle HDR, but I did not need it. Now, in problem 13 here, we have another word bank. I'm hoping that you're getting better. Okay. I'm hoping that you're getting better. We have 2 problems left and we're done with notes. So 13, go ahead, give it a try. I got a word bank set up. Turn me off and do it and then turn it back on. Well, welcome back. Hey, my first thing, let's get our given down. I got my given. I got segment BC congruent to segment DC, segment AC congruent to segment EC, and I've got my step 1. That's my step 1. And my reason 1, given. Now, after I do the given, I haven't done this a lot, but let's investigate our picture. I know BC, I know DC, okay, I know where those are. I know AC, oh, you know something. These right here, that's vertical, that's a bow tie look. I got vertical angle theorem. So I'm gonna talk about angles, those 2 angles being congruent to each other because of vertical angle theorem. So I got BCA and DCE congruent to each other because of vertical angle theorem. Boy, I'm pumped up about that. That was my step 2. Okay, step 3, because I have side, angle, side, this is our shortcut today. Because I have a side, an angle, and a side, the angle, and a side, I now know that these 2 triangles are congruent because of side, angle, side congruence. Boy, these are really nice compared to the ones we did yesterday. We don't have to do as much, and it kind of seems to make more sense, I'm hoping. Okay, so make sure you're paying attention to these. These are very similar to what we're going to be doing on today's assignment. And remember, I will change letters and have them similar, so make sure you're comfortable with trying them and talk to other people about them today. Remember, talk to people, work together, make sure you're getting it done. Now, in 14, turn it off, give it a try. And then we'll turn it back on and see what's on. I've got a word bank there. Give it a try. Now I'll make it a little bit better so you can see them all. Okay, welcome back. Now, remember, after you get your given down, and you already did that, you're just really pumped up about that first step, look at your diagram and mark up what you have. I have parallel lines right there, and they're congruent. But it's important to keep in mind that parallel lines are going to give me alternate interior angles. I also have reflexive. This should be reflexive. Oh, you know something. This is congruent to this, and I'm going to be able to say that the two triangles are congruent because a side angle side, okay, after I talk about my reflexive side and my alternate interior angles. So now I've got my alternate interior angles, my reflexive down. I put that reflexive in, and I'm able to look at my reflexive. And now remember, I said reflexive and then alternate interior angles. So now I have my alternate interior angles, okay? And after I get my alternate interior angles in, I'm thinking these two triangles are congruent because of side angle side. And I'm done with my other shortcut. Now, keep in mind, I've got a couple people out there that tried this, and they were like, Bloom, what's the deal? So I have my step 2 and 3 switched. So here you go. You ready? What if they decided to do this, and instead of doing the reflexive property, they saw it as alternate interior angles. Then they saw reflexive property, and then they saw my side angle side. Would that have been wrong? Okay, it's not. 2 and 3 have to happen. They can happen in either order, but generally my first thing is my given, and then I have my alternate interiors, my reflexive side angle side, or I have my given, my reflexive alternate interior angles, and then side angle side. That's up to the person doing the proof. Okay, I hope that's helpful. That's notes today. The person that's subbing today should be handing you out the assignment so that you can get that done in class. Thanks for your time today.